Okay. So everybody got started with lab 3? Yeah. Easy? Should I give you some help maybe? Okay. I got not everything. I got the most difficult part. How about that? Okay. I got something prepared for you. Okay. But we're gonna make sure we don't talk about this more than 10 or 15 minutes. That'll be too much. But okay, I'll try my best. I will just tell you exactly what the concept you're really going to learn for lab 3. We are going to talk about again after the reading week when we talk about state design pattern. But I'll just illustrate it to you. The two classes you want to pay attention now to learn about this pattern here, and you will basically reproduce the same pattern in your case. Okay, I will show you the bound diagram that you were given to tell you the classes you look at. Okay, so these are the two things I'll give to you. So now, number one. Remember last time, before at the end, we said about sorted model ADT, sorted map ADT, which is deferred. And also, we got another class, which is descendant sorted model map, right? So these are the two classes. Now, let me highlight again the feature I want to show you the pattern about. First of all, I want you to look at the feature called instance over here. Okay, instance. You can see that for this particular feature, it is deferred, right? Which means it is unimplemented at this level here. However, there is another feature over here which is not deferred, called submap. However, this non-deferred feature here uses the deferred feature instance. Okay, first of all, I want to draw your attention to this. Okay, so far? Okay, so now, I'll talk about the runtime in just a moment. As I said before, this is so-called template design pattern. Let me just mention again. And I'll illustrate to you how this will work. Template. And we'll reiterate this concept again when we talk about inheritance and state design pattern. Okay, template. And then one thing to notice. Now, in this particular subclass, because sorted model map, right? This class is effective, which means every feature is implemented, right? So now, I want you to pay attention. Where does instance feature go in this particular class? Okay, let's highlight it quickly. It's exactly here, instance over here. And then, by the way, light current is so-called anchor type. Okay, that should be part of your iPhone 101, but I'll just mention that here. So light current over here is so-called anchor type, anchor. Which means whatever the current class is, which is sorted model map, is going to be that type. Okay? This will be particularly useful when we talk about inheritance. Okay? Especially you can see that if you look at light current over here for instance over here, when you say light current, the current here refers to sorted map ADT, right? But at the subclass level, when you say light current, it refers to just the subclass. In your case, you're going to implement different map using a binary search tree or maybe a red black tree, etc. Those will be just different type because the current will be different. Okay, that's anchor type, first of all. You can see that over here, we really make the instance feature effective. So I'll put a plus over here. You can see the way we effect that is by saying create result that make empty. Okay, so what this does effectively, we are basically creating an object for instance of a dynamic type called sorted model map. Okay, that's what we're doing here. But I'll illustrate to you at the runtime. Okay. One more thing to say. Can you find the definition in this particular class called submap over here? In this class per se, you cannot find it, right? Which means it's completely inherited from this class over here. That's why it's called template. You only define the submap definition over here in this particular class at the deferred level. However, as long as at the subclass level over here, you try to just make the instance, which is a critical step over here, effective, everything else will just work. But now, how exactly, right? So let me just put, I'll illustrate in the bound diagram. Let me just show you a fragment of code here. You can also try and use debugger to convince yourself. Let's say we declare a variable called n. The type is simply sorted map ADT. Let's not worry about the key and value in generics. Okay, sorted map ADT. So this is the so-called static type, which means dynamically I can assign any class that is a subclass of this class, right? In this case, let's say sorted model map. And now let's consider this guy here. That's the interesting part. Okay. So now when we say creates, and then as I mentioned last time briefly, whatever you put inside the curly brackets, so this is the so-called dynamic type. Okay, we'll talk about static versus dynamic next week when we talk about inheritance. Dynamic type, which means dynamically, this is the class definition you're using dynamically. And that will simply make an empty map. Okay? So now the question is, when I say m.submap, how does that work exactly? That's the question. Now, let me just highlight the fragment in the code, and then we'll illustrate that in some diagram. When I say m.submap, I know dynamically this is indeed a sorted model map, right? That's the type. Now, when I execute the submap feature here, tell me first of all, which fragment of code of submap is going to be called? In the sorted map ADT, right? Exactly over here. However, when I try to execute this block of code, especially when I encounter over here, at the sorted map ADT level, well, this instance was undefined, right? It was simply just deferred, as you can see. However, since the current object is of type sorted model map, that means I can refer to the instance over here is so-called dynamic binding, which means depending on the current type of the object you're calling, it's going to call the corresponding version for every feature, right? In this case, in the instance over here, you're just going to call this particular instance feature, which means like current would simply give you the current type, which is sorted model map. And then you simply just create this particular instance for you, and then the rest will just follow the definition for the template. Kind of make sense? Okay, let's just visualize very quickly. The reason that it's so important to talk about this is because you do exactly the same, just in a different cluster. Okay? So now let me just illustrate to you quickly. So let's draw some diagram here. So now let's say over here, what does it really mean when you say creates? What you're doing over here is like this. So you have n, which is pointing to some objects over here, right? And the object type is simply sorted model map. That's a dynamic type, sorted model map, okay? And there are two features you have to pay attention to. Number one, let me just put it here. Number one is the submap feature. The other one is the instance feature. Okay, so these are the two things that will make together things work. Now for the instance over here, okay, I will just put orange over here. The instance is exactly the definition we put over here. That's the definition, okay? So this instance over here is going to create an empty sorted model map. Okay, that's the orange part. On the other hand, the, let me use maybe green over here, for the submap over here. So this one over here is going to use the template from the superclass over here, which is sorted map ADT, okay, which is exactly over here. So these two things come from different places, okay? So now, one thing to note, what's really the advantage of doing this? Every time when you're trying to create a new descendants for sorted map ADT, which can be, let's say, example. By the way, you have looked at this diagram already, right? If you haven't, please do, all right? Let me highlight some critical things for you. We got sorted map ADT over here, and the one we just talked about was the sorted map model map, right? You got other descendant classes as well. For example, you have, by the way, this is inheritance, right? Just the way we draw is like a horizontal, right? It should be vertical. We got sorted redback tree, we got sorted binary search tree, and also sorted linear map. So 1, 2, 3, and 4. We got 4 different descendant classes for sorted map ADT, right? However, imagine if we didn't actually declare this particular template at the sorted map ADT level. If you simply duplicate the same code in all the 4 descendant classes, that's not a good design. We want to factor out the template, the common part, into the deferred class. That's what we're doing here. All you have to do in every descendant is just to make the instance feature over here effective, to tell the runtime exactly what model map you're going to create. It could be model map, it could be binary search tree, or it can be redback tree, right? Make sense, guys? Any point you're confused with, raise your hand now. Please let me know. Yes? Sure. The diagram simply means this. At the runtime, first of all, from this line over here, right? Okay, we are creating an object of type sorted model map. Okay, that's what we're doing. And then let's say we're calling this particular feature called submap. That's what we're doing, right? The submap map is tricky in the sense that it doesn't entirely come from either sorted map ADT or entirely come from the sorted model map. It actually comes from two parts. First of all, overall structure about the algorithm of calculated submap comes from the template, which is sorted map ADT, the superclass, right? That's completely inherited. However, this critical line, critical expression over here, which instance of map are you calling? That's the part we delay the decision to the descending classes. In this case, you can see in the case of sorted model map, we simply say instance should be make result make empty. And what makes this work is we have the anchor type like current. Because at this level here, when you got sorted model map, the current will just be sorted model map, right? If you go into your class, let's say sorted, let me give you one example. If you go to this particular class called sorted RBT map, and then you simply redeclare your instance feature over there, and then you say like current. So now the current, what does the current denote in this case? Sorted red black tree map, right? So that's why anchor type is so useful. Okay? Better, I hope. So basically, there are two parts of the execution you have to be aware of at the runtime. Okay? Now, for every descending class, you don't have to duplicate this definition again. All you have to do is to make this particular critical step effective. That's all you're doing. Okay. Yes?
What's the difference between like and colon?
Like, oh, what's the difference between like and colon? Okay. So now, let me, they are very different. Okay. That they simply are just different, well, just different. Let me show you. So when you say, let's say instance like current, I tell you this, let me, you know what? Let me put it this way for you. How about this? For your complete understanding. Let's say we don't use the like current. Let's see what's going to happen. Let's say we simply got a following hierarchy of inheritance. Okay, A, the parent class, and then here we got B, and then over here we got C, right? A, B, and C. Let's say we have a feature called F, which returns just A. Okay, and then here we got the same feature over here, and then we simply want to override it. By the way, overriding also is supported in iPhone. And the way you say overriding is you use ++, which means we are redefining that. Okay. Over here, I want to say, rather than returning A, I want to return more specifically B, which is allowed. Okay. Also over here, I can say C over here. Okay. So now, anchor type tries to save you some typing, also make things more manageable. Okay. In this way. Because imagine that if you got 100 different descending classes for A, in which case you got to make sure every time when you put the return type over here, you have to put something corresponding to the current descendants. That can be quite a bit of job to do the housekeeping. So now what we can do instead is to say this. So now you can say F is simply like current. And the current here refers to just A. Okay? And then if I do this over here, I got B here, I got C here. And then F++, okay, plus redefine. And then rather than saying just B, I can say like current. And over here, F++, I can say like current again. So now you can see that the current over here refers to B, and the current over here refers to C. You simply anchor the current class, right? Okay, so now back to your question, how are they different? They're very different, right? The colon here simply declare what follows that should be a return type. And to specify return type, you can either say a concrete class, or you can simply say like current. Right? No, you cannot say that. Yeah, you're basically asking this. If I say F over here, just say current, right? No, it doesn't make sense because if you say current refers to an object. It doesn't really refer to a type. But when you say like current, like has a special meaning that the compiler will know how to interpret. So it's different. Okay? It's good that you asked that. No. Like? You can, you know what? Anchor type can go a little bit further. Okay, let me just say one more. Okay, just since that we talk about anchor type. You can also, let's say I got another feature here. Let's say I got another attribute here. Let's say attribute is simply account, for example. Okay, just some class. And now I can have another attribute over here, C. I can say like A. Basically, I'm saying whatever type C should be correspond to the type for A. It's kind of relative, right? So which means as soon as you fix X type, the type for A maybe into bank, that means the type for C changes automatically, right? It's more like a symbolic link. No, you cannot use C colon A. You gotta use the like over there. So like has a very special meaning. It will retrieve the type for that particular either current or attribute you're referring to. Okay? Okay, guys, are we okay? Yeah, this is kind of out of topic, but that's okay. So you can feel free to use anchor type. Okay, now let me go a little bit further. We are comfortable with this, right? Just template. We'll go much more detail into template design when we talk about state design pattern. But now, what will be relevant to your lab number 3? Okay? As long as you understand how I just explained in the previous page about how the submap will be executed at the runtime by effecting the instance, right? You do basically the same thing for your lab 3. Let me highlight the thing you should really pay attention to on the diagram. Number 1, you want to really pay attention to this particular class, right? You can see the way we tell you what classes you should really make. There are 2 ways, either from the diagram or from the ES test we gave to you, right? We kind of enforce the kind of hierarchy you should have, okay? So now pay attention to this particular class, sorted map design, okay? That will be the class you have to somehow declare something similar to this guy here, similar, right? Where you actually also try to specify some template, like a submap, okay? I'm just talking about analogy here. So in sorted map design, you will do something like the submap and instance, as you can observe from this class over here. You do something similar, okay? And now, what else? What you should really see, another thing is, have a look at 2 client-supplier relation over here. You can see there is a client-supplier relation. We're saying that the sorted map design should have a supplier from the sorted ADT, right? And sorted ADT is just another cluster, which contains either sorted linear, sorted tree, sorted binary search tree, or sorted wrap-like tree, right? That's just another hierarchy. So now, when we say at this particular superclass level, we simply keep the implementation deferred. However, it doesn't really mean you cannot define a template for other things, like how we did for the submap in the sorted map ADT. Okay? So you will have to do something like, I'm not saying you have to, something like submap over here. Something like submap here, and then which is going to use implementation. Okay? And then at the descending class level, you will do something very similar to what you did for sorted model map over here, in which case we simply make some concrete implementation for instance. But in this case, you may have to make some concrete things for implementation in these 3 classes. Okay? If you don't quite know exactly what I meant, maybe try to look into the lab a little bit further and rewatch the recording. I think pretty much gave you quite a bit of hints. Okay. Any questions for me for lab 3? I can take just 1 or 2 more minutes before we go to the topic. Okay. We're okay for this? Okay, lab 3 is challenging, but I think it does teach you a particular pattern for object-oriented programming or design. Okay, so do take the advantage for that. Okay. But if you got trouble, you can still drop by my office hour. We still have time, right, before lab 3 is due. Or you can ask me on Friday. Okay, after this, let's go back to our iterator pattern. Okay, again, the number 1 principle you have to know about iterator pattern is we're trying to do information hiding. So information hiding is really about you want to hide the secrets for the supplier so that when you want to change the secret from one to another, it's not going to affect the clients. That's how you think about information hiding in general. Okay. Now for iterator pattern, let me just, so that's the diagram we talk about, right? So I'm going to assume you're reasonably familiar with it. Okay. So now what I want to do is that can be also help to your lab 3 as well. How do we implement the iterator pattern as a supplier? So there are 2 ways you might go. Either go for the easy route or you go for the hard route. So easy route is very easy. if you can already return a new cursor from some collection attribute, just use it. Okay, that's an easy way, so we don't have to repeat. I do want to talk about the hot root a little bit more. Okay, that hopefully can also help for you to do lab 3. Now, let me just mention something here. Basically, what we want to do, let's see this particular example here, right, which we looked at last time. Let's say we have a book class over here, and then we want to make it iterable. So we'll simply say inherits, and then iterable, right, iterable. And then we're going to pass something over here. And then whatever this is, it should be, you think about when you return an iterator object, it's going to return one item at a time. What should be the type of that particular item? The type should really contain all the information necessary for the book. In this case, for the book, since we got name and we got records, so it should be a pair of the name and the record. So that means we can, one option would be, you can simply say tuple, and then you can simply give the string and also G. Okay, that's one option here. However, it doesn't really mean you cannot just create a new class yourself. I'll give you one example, right? Just, you want to be creative sometimes. What you could have done would be, you can define another class over here. Let's say my pair. Let's say my record. Oh, actually, you know what? Just record. Let's say book record. And the book record is going to take some generic parameter G over here. And then let's make it very simple. And this is only a single record, right? In that case, we can say we have name, which is always going to be a string. And also we have record, which is going to correspond to whatever G we're going to instantiate that into. Okay? And now over here for iterable, rather than having tuple, you have another option. You can say book record. And then you simply pass. So now what should I pass over here? Should I pass string or should I pass something else? How many things should I pass first of all? 2? I heard 2. Are you sure? Look at the definition for book record over here. How many generic parameters do we have? Only 1, right? So you can only pass 1. Now make a choice. Should you pass string or pass G? G. Why not pass string? Huh? Oh, actually, you know what? I tell you what, it would be okay if you simply pass string over here. It will compile, I tell you what. If you only worry about compilation, I can tell you that's not an issue. It will still compile if you simply say my record of string. However, there's a logical design error over here. What is that? Aha, exactly. Because, let me just repeat what Ken just said, which is exactly correct. Over here, you can see that if I simply pass string over here, that means I'm replacing G just by string. And which means this will also be replaced by string. That means I'm constraining the book, the record, to be always storing string name and string record. That's not good. Okay? I will give you guys even more challenging exercise next time. Okay? To really figure out exactly what kind of generic parameter you should really pass. Okay? That's really worth doing. Okay, good. So now what we should do over here is, instead of this, we should really put just G. That's just another option for you. Okay? After this, we have to give new cursor over here. Okay, and then, so now what should be the type over here, right? Typically, it should be iteration cursor, because you can see that from the diagram over here, what should be the type for new cursor? You can see from there, it's iteration cursor. That is why you see a client supplier, so the supplier side is simply iteration cursor. However, in the hard approach, you cannot just return, for example, new cursor from the array or from the linked list. You have to create a cursor yourself. In that case, you have to be more specific about what the cursor type is. In that case, I can simply say, for example, let me just remember what's the name, my iteration cursor. I can simply put my iteration cursor. And then I can simply pass the same thing. Okay, just tuple. Okay, I'll just say tuple, and then string, and then G. However, there's one thing you have to note. Whatever I put over here must be a descendant class or subclass of iteration cursor. That's exactly what I will show you, how you can do it. Okay, and then And then over here, you can simply just create an instance of my iteration cursor, and then that'll be it. Now, the question really is, how do you implement this? Right? That's a question, right? Let's just go over the big picture here, and then let's see, then we'll go on with the details. So now for the hard approach, basically what we're doing is this. I started with my own class called book, okay, which is of type G. And then I'm trying to say my book is going to inherit. Okay, let me just put it here. My book is going to inherit, so this is inheritance over here. It's going to inherit from iterable. And then my book is going to return a new cursor that is not directly iteration cursor. So what I'm trying to do here, okay, I'm going to show you some inheritance relationship here. So basically what I'm doing is I'm creating another class over here called my iteration cursor. My iteration cursor. And then it's just going to be a subclass of the iteration cursor over here, right? You can see two inheritance over here. And then between them, I have another client supplier. And then what should be the label for the client supplier? New cursor. The only difference is this is deferred. This is effective. Okay? Now, are we okay with the pink, green, and orange over here? Are we okay with that? That's basically what you have to do, the kind of inheritance hierarchy you have to create and client supplier if you want to implement the iterator pattern yourself. Okay? Now, I'll give you a little bit more details, which is also on the slides. How can you implement my iteration cursor? As soon as you say my iteration cursor is a subclass of iteration cursor, you're obliged to implement all the features over here after item and fourth. Okay? And then, if you see the slides, again, I'm trying to duplicate the hierarchy over here again, as you can see, right? Again, we got iterable, which is a superclass of book, and also we got iteration cursor, which is a superclass of my iteration cursor, right? That's what we have. And then we got new cursor here, which is deferred. We got new cursor here, that's effective, right? Now, what should we implement, right? You got to implement basically item, after, and fourth, okay? So now, I'm going to explain, rather than telling you exactly what lines of code you have to write, let's try to explain to you how exactly things will work at the runtime by using some diagram. So that will give you some inspiration, okay? Let me just show you something over here. You can see for my, it's a very standard way of implementing stuff. There's one way. If I got my iteration cursor over here, right? So I have some private, so this is information hiding, which means I'm hiding these three stuff from the clients. The client can never get access to this. I may later on change my secrets, which the client wouldn't be affected about, okay? So I got the cursor position, which means where is the cursor? The cursor is going to point to somewhere in the book, somewhere, okay? And then it's going to be internally names and records over here is simply the alias from the original records, okay? Let's have a look, some visualization, okay? Now, let me make, so let's see how that will work. So now, of course, in this case, maybe I'm really meant to say book, okay? Okay, we're talking about book example. So now, let's see how we can do it. I do have some color convention over here. Whenever you see the dark color over here, that means they are private, okay? When you see the green one over here, that means it is public. The clients can get access to the feature that's in green, okay? Similarly, for the iteration cursor over here, okay, that's also, this should be, actually I should change the name. Let me also change it over here. That should be my iteration cursor. My iteration cursor, which is exactly what I'm trying to implement over here, okay? So now let's try to understand the design overall at the runtime, okay? At the runtime, me as a client, if I want to really go over the book over here, line by line, over here. If I want to go over the book line by line, I definitely cannot just go to names and records. I cannot, because they're private, right? They're hidden from me, right? Because the supplier might change them to hash table, might change them to binary search tree later, so they don't give me access to the names and the records. What I can do is the clients. Think about what the clients can get access to. For the clients, they will simply say, they will declare, let's say, B of type book. And then they can have another, let's say, C cursor, let's say iteration cursor, and then it will say C is assigned to B dot new cursor. This is what the clients can do. Okay, they cannot get access to names and records directly. All they can do is they can say, now give me a cursor that is going to iterate through the book in one by one. Okay? So now let's imagine how things will work. Okay? So now, typically what the clients will write is something like this. They will simply say from the client code. They would say from, so we got cursor C over here, from C dot start until C dot after do and end. And for this part here, we can say C dot item, and also we can say C dot fourth. And you can see this. You can see specifically for the after and fourth. So these are the two features you have to implement, right? As a supplier for the iteration cursor, for the my cursor. So these are the two operation and also item. So these are the things you have to implement in order to support this. Let's see how they work together. Okay. So now for the client side, let's say if they try to really go over, try to execute this code at the runtime from the client side, what's going to happen is this. First of all, when they say new cursor, let's say b.new cursor, right? So b.new cursor is simply just going to return this particular cursor objects over here, right? This is objects. And then we assign that particular cursor objects to C. So that means you can think about C is the reference the client get, and it's pointing to this particular objects. Are we okay so far? Okay, so now C is really pointing to this particular my iteration cursor objects. Again, the clients cannot really get access to anything that's internal to the cursor. The client should never ever be able to do that, right? All the clients can do is to call the item, call the after, and call the fourth, just like what I'm doing over here. Okay, let's see how things work right now. Okay, so now initially the cursor objects over here is simply just pointing to, internally, is pointing to the first name and also point to the first record. So conceptually, you can think about this is the pair of things that we would like to return back to the clients, right? That's what we like to do. And what you will see is when the clients call C.item the first time, what they would do is, you can think about over here, what you really should return is just a tuple, which means the supplier for my iteration cursor should really say, for the item, you want to return just a tuple. So now over here, out of this, you're simply just going to create a tuple that's something like names at position 1, and also records at position 1. So this tuple over here is just going to be returned back to the clients. Okay, not really the underlying collection. Are we okay so far? Yeah. Guys, if you can just let me know if you're okay or not. Right. Okay, right? I'll take silence as yes. You're okay. Right. Okay, and one more thing to say. And when the clients call the fourth, in this case, maybe what you would do internally, you will simply update the cursor position over here. Used to be just 1. And you can update the cursor position from 1 to 2. In which case, it goes like this. So now rather than pointing to these two things, it's going to point to, let's say, this particular second element here, and also the second element over here. So they together should make the second item to be returned for the clients, right? So internally, for your item feature over here, you should really create a tuple from there, right? Based on the cursor position. And then that will simply be names at position 2, and also records at position 2. Okay, let me say one more thing, and then I'll take questions if you have. Recap. For the iterator pattern, the bottom line is the client should never be able to get access to the internal data structure, which should be hidden, according to the information hiding principle. All the clients can do is to get access to the new cursor return value, which is going to be some iteration cursor objects. the iteration cursor objects will allow the clients to use it like a cursor, which means they can call item, they can call after, they can call forth, like the loop over here. I'll give you more example about the client side after this. And then you can see that for each iteration, the cursor over there is going to just point to different places. For example, starting with the first iteration, just point to the first pair of items over here. In the second iteration, they will point to the second pair of records, and so on. So every time you only return one pair of items back to the clients. Yes? Yeah.
Only you should be able to access get set. Is this like the same idea where?
I would say for this particular illustration here, you can think about, yes, you can think about the names and records, and also values 1, values 2, and cursor position in the dark color. They're simply private, yes. Which means anyone using the book class or using the my iteration cursor class, they simply cannot get access to these attributes. Yes. Yeah. Okay, questions? Yes. The relation slides? This one? Yeah.
So book inherits from iterable, right?
Yep.
There's some defer method, the new cursor is deferred right there. So you're saying we can implement the new cursor method by
creating a new class yourself. And the way we did it is by just creating a new class over here, my iteration cursor. But the class must be a subclass of iteration cursor. That's a constraint. You can think about, okay, well, thinking this way. You can think about the iterator pattern is really about the iterable and also the iteration cursor. So these are the deferred classes that will constrain how you implement the iterator pattern, right? How you implement it, you have to make sure there's maybe some class you want it to be iterable, and there might be another class for which you support a cursor operation, right? So there are two parts, right? So for the iterator pattern, actually that might be a nice summary. For the iterator pattern, you want to make sure something is iterable. To make something iterable, you want to support some kind of cursor. So these are the two concepts over here for the iterator pattern. Questions? Yes, you can use a cross, yes. Good question. We'll get there. We'll get there. Your question was, when we use the across loop, do we have to use the cursor? It's both yes and no, depending on how you use it. Yep. Yep.
When I was using the cross loop
Mm-hmm.
for an array, I remember I used a cursor index.
Yes, cursor index, definitely. Cursor index is simply just another feature you may use from the iterator pattern. Yes, that's something you didn't really mention. That's something you can also call, yes. Oh, I just didn't show it over here. Yes, so if you look at the, I didn't really show it here, but I believe as part of the iteration cursor over here, there is another feature you can use, which is called cursor index. Cursor index is not really required for you to actually use, but cursor index simply show you where you are for that particular iteration. But at the position, yes. Yeah. But I typically don't really use cursor index myself. I can easily get around from that. Yeah. But if you want to use it, feel free. That's fine. Yeah. Okay. Any questions about iterator pattern? So the best way for you to understand iterator pattern, just understand what I'm trying to showing here for the architecture here, and also this diagram here is really important for you to understand why we are doing this. We're hiding something from the clients, only exposing the cursor operation to the clients. That's what the iterator pattern is about. Okay. Now let's see more example about using the iterator pattern. So now we are done with the supplier side. We want to see how to complete the picture to see how the clients might use anything that's iterable. Okay. So now let's see this. Basically, you can use the iterable in both the contracts and in the implementation. So both are possible. So I'll show you all the examples. Okay. So now let's see the first one. Okay. We have seen many of them already, but I'll just show you some new concept over here. Okay. Here you can see that we have collection. Okay. There's an attribute. We simply say it's iterable, and then integer. Okay. One thing to note, it's kind of interesting to actually show you. Okay. you can see that over here, we simply say whatever the type for collection is simply just iterable rather than just array or linked list. Okay, there is a reason for that. Okay, there is a principle over there. I want to show you this on the slides. It's called code to the interface, but not to the implementation. So now let me show you over here. Let me see where it is. I think somewhere on the slides. Yes, over here. Okay, obey the code to the interface, but not to the implementation, which means over here. So now if I go back to the slide, iPad over here. So now when I declare this particular attribute over here, I'm basically debating myself. What type should I put for collection? So now it would be a design decision for you to make. What kind of type should you really declare for a particular feature or attributes? Here's the principle. Think about how you're going to use the attributes. In this case, all I want to do with the collection is I want to iterate over it. Nothing else. I don't want to call any array specific or linked list specific feature on this particular collection attributes. So all I can do is just say it's iterable. That will make sure all the iterable structure will be supported on this particular attributes. Okay? Okay, so now let's see over here. How do I write a contract, right? It's all positive. And now you can see one example is very easy. I simply say across the collection, you can see over here I don't need a cursor index. I just want to go over every element without knowing where they are. But in this case, I don't need to. Okay, across the cursor now, one thing to note, where is the cursor? Where is the new cursor? Implicitly, whenever we say this cursor variable over here, it's implicitly the following. It's going to say cursor is simply assigned to collection.new cursor. Implicitly, this is what happened. Okay, IFO just does that for you whenever you use the across feature. Okay, across the construct over here, and then you say that is why you always had to say cursor.item. So now you can see a little bit more, right? Because cursor is simply of type iteration cursor. That's why you had to call the item to know where we are pointing to. Yes. It's like a for each loop in some way. Yes. It's like a for each loop in Java. Yes. Yes. Idea is really identical, just a different way of supporting it, right? But I think what we are trying to emphasize over here is more about why we choose the iterator pattern. We want to hide all the information about the implementation, right? We want to expose only the cursor operation to the client. Yeah. Okay, good. Okay, that's just one example here. And then you can see that we can write an equivalent loop also over here. So now over here, let's say I just choose another type over here. Let's say list. List is also a collection which is also iterable. So let's say we got a list of accounts. So I just want to show you here, we have seen this already. You can also say across, and then this particular notation which we have seen is simply just creating some integer interval on the fly. And this interval over here is also iterable by default. So this is creating an iterable interval. And then we're simply using a cursor for that, right? That's something you want to pay attention to. Are we okay so far? Okay. Okay, it's about using it. The next one, now let's do some exercise together. This one will be fun. Let's say we have over here, I'll make it a little bit bigger for you. So now, let's say we got accounts, which is of type a list of accounts, okay? And then I have a Boolean predicate over here, a Boolean feature, which just contains duplicate or not, either true or false. Now, you can do whatever you like over here, possibly a nested loop. And this is the contract I would like you to write. I'm being kind to you. I give you the universal quantification, okay? Can we just try to understand this quickly, right? We're saying for every pair of indices I and j for the list, right? I and j integer. So I must be a valid index, and j must be a valid index as well, right? I and j. And now what I'm trying to say over here is if the accounts at position I is the same as the account at position j, if they're the same, using object comparison, right? Comparing their contents. If the accounts are the same, that simply means I and j are the same. So this is how we check for duplicates. You learned about something called control positive, right? In 1019. What, does it ring the bell? You heard about this, at least this term, right? Counter positive. Anyone want to tell me what counter positive is? Just in general. Yeah, if you say P implies Q, it's the same as saying not Q implies not P. Okay? Yeah, counter positive. Okay? So if you got P implies Q, it's equivalent to say not Q implies not P. Okay? Now, how do I rewrite this guy over here using counter positive? Well, I simply say I not equal to J implies accounts at position I is not the same as accounts at position J. So they are equivalents, right? That's also one way to say it's has no duplicates. For every pair of I and J, if they are different indices, that means the associated account should be different. So there should be no duplicate of the account. Either way works, but they're equivalent logically. You okay? Good. I will make sure. Yes. It looks a bit puzzling. So, okay, guys, are we okay for it for the mathematical part? Now, question is, how do you turn this into iPhone? Let's do it together, right? Let's see this. Okay, let me just add a new page over here. Naively, you might try this. Naively, if you say across, for example, I 1 until let me just be consistent. Accounts to account. As naively, you might simply say as I comma J. Naively, right? No, you cannot do that. Each across can only introduce one cursor variable, not two, I'm afraid. Now, how can we get around with that? Use another across, right? Now, how do we do that? Of course, write another across, right? So now, let's try that quickly. I'll give you the overall structure, and then you do the rest. So now, we can say, introduce the first one, which will be I, and then, as part of it, I can say across, and then 1 until accounts dot count as J. End. Okay, and can you do the implication over here? Yes? Oh, interesting. Yes. You try to be a little bit more efficient in the contract. Yes, you may. Yes. What you're asking was, can I simply put, for example, rather than 1 here, can I put I.item? I believe you can. Double check for me. I believe you can. Yes. Yes. But you know what? Since we talk about logic over here, you don't have to encode too much implementation detail. In the loop, you can definitely do it. Yes. You know, it's a good question here. You are basically asking, well, think about where, it's a good question. Think about where we're going to put this, right? If you look at the original question here, this is part of the ensure clause, right? Which means everything we put here must be a Boolean. You're basically asking, which is a valid question, you're asking, can I simply say, maybe, I've seen this in the lab test. Make sure you are not one of the students like this. You might say, part of the ensure is say local, ij integer, and then do, maybe, everything under this particular ensure. And then you simply say, from, until, and then loop, and then end, right? You can put initialize I and j, and etc. That's simply not going to compile, right? Because whatever you put inside the ensure must be a Boolean. It cannot be an instruction like a loop. Okay? Yeah. Yeah, it's an ensure, right? We're writing a contract, which means everything must be a Boolean. No, you cannot have local in ensure. The only way for you to introduce local variables is using a cross, in which case you have a cursor variable. That's the only way.
What if inside you have an if statement which decides Boolean output?
You mean for the from? Okay, from until?
What? Inside decide what to do?
Oh yeah, sure, you might. I'm just saying the fact that you're trying to put the from until loop in the context of ensure is simply wrong. You just cannot do it. Because the from until loop is a loop. The loop doesn't really return anything back to you.
Right, so I'm
Yeah.
saying return the boot.
No, it doesn't work that way. Yeah. It works conceptually, but doesn't work syntactically. Right? Yeah, okay? Again, so it's really important for you to remember every time you want to do require, ensure, or invariance, always put a Boolean. Okay? Yeah, we have time. Good. All right. Now, let's see the next one. Oh, this one here actually shows you if you really like, you can definitely bring the new cursor into play. If you don't use the across loop, you can definitely choose to use the from, until, do, and end, this pattern over here. In which case, all you got to do is define a local variable here. So here we can define a local variable because we're talking about implementation, different context, right? So now I can declare iteration cursor here, and then I simply say whatever, let's say accounts is iterable. So I simply say, so this is a critical line. I say cursor is assigned to accounts.new cursor, right? So now I can use this cursor like a cursor, right? I can say, as soon as you create a cursor, it's ready at the first position, right? And then you can say until the cursor has run out of the items to return to you, and also cursor the item, cursor the fourth. By the way, this part, this code over here is exactly equivalent to if you simply say across. Okay, across the accounts. Oops, sorry. The accounts as cursor, and then you say loop over here, and then end, right? And over here, notice one thing. In the case you want to use a new cursor by yourself, you must say cursor.fourth. You must say that manually. However, if you simply have a cross, the cross does the fourth for you implicitly, so you don't need to say that. Okay? So all you got to say is, you're going to say, for example, max is assigned to cursor.item. Okay, and over here, no need to say cursor dot fourth. You don't need to do that. Okay, one thing to know. So you don't need to do it, but at the same time, this version here you have to. Okay, yeah, it's a bit implementation detail. I'm just highlighting it to you, in case you are curious about how to do each version. Questions about this? Okay, as a client, you might either use new cursor, or you might use a cross loop, basically. Right? Either way is fine. Okay, let's see more ideas over here. Okay, actually this one exactly what I just mentioned. So now over here you can see that we have again. Remember we make our cart example, right? Iterable. So now you can say across. Notice that when I say across and loop, there is nothing like cursor.fourth, right? You don't have to. Across does that for you implicitly. Okay. Notice again, no cursor dot fourth. You don't need to say that. Okay. You just don't have to. Okay. Good. Guys, questions? Okay. We have seen many examples like this already, so I don't need to bother you with details. Okay. Okay. Now, any questions before I draw a closure on iterator pattern? I tell you what, the best way to understand iterator pattern is by programming that yourself to see the details. But I think at least what I showed to you is on a high level, right? To see how things should be hidden from the client point of view, and then what should be exposing to them. So these are the two things you want to keep in mind. Okay? So we do have some resources for you. Okay, that could be the last minute's help for your lab 3. If you, so everything has been talked about, so I want to go to, okay, I want to go to this particular slide quickly, okay, over here. So there is a page called resources, which I want to show you. Oh, let me see that, if I have it here. Yes, over here. Okay, for this particular page, I made some tutorial videos for you, so that shows you exactly how you can develop the iterator pattern step by step. If you still need help on that, that'll be some place to go. Okay, you can just click on that. So we do have some videos for you if you want to know how to implement that. Okay, we'll also cover generic parameters and also information hiding. So these are the two things we keep emphasizing about. If no questions, I will go to the next pattern. Okay, Singleton. Okay, which is kind of interesting. If you knew already how to implement that, you might get some new insight from this particular discussion. Okay, now let's consider two problems over here. Every time before we talk about a particular design pattern, we want to consider problems first before we present to you a solution. And usually, before I really present to you the actual pattern, I want to give you some working solution, but may not be so good design, right? You always want to appreciate what the problem is and also why other possible solution may not be as good as the actual pattern, right? So these are also important stuff for you to know. Okay, let's see, we'll consider two problems over here. Number one, let's say we talk about bank accounts, right? And the bank accounts actually want to, we got the various data for the bank account. You might got interest rate, exchange rates. You also got minimum balance and maximum balance, stuff like that. Okay, so these are the data that every account might have to share. Okay. Also, for those of you who took the operating system class, we talk about processes, right? Sometimes you may want to have some shared resources among the threads or among the processes. That's another scenario. Let's say you got a single printer to be shared among processes. So now let's consider one design, and we will criticize on that together. Let me show you some animation first, and then we'll go to the iPad. Okay. So now let's say we got basically imagine that we got a shared data class. Okay, and then I'm going to show you the shared data how it looks like. The shared data basically contains the various attribute values over there. And then we have a class called deposit. As far as deposit is concerned, deposit only have to worry about the maximum balance to make sure you don't deposit too much, let's say, into a particular account. Okay? We have another class called withdraw. And the withdraw only have to worry about the minimum balance. Make sure you don't really withdraw below 0, right? Okay. So basically every transaction type has only a subset of the attributes they should worry about, not necessarily all of them, okay? And let's say for international transfer, you have to worry about exchange rate, right? Okay? And also for, okay, that's it. And then you also have another class called account, in which case you have to worry about interest rate, right? So now we got 4 classes. We got deposit, we got withdrawal, we got international transfer, we got account. Every one of them has different set of data they worry about. Not all of them. And this is the class called shared data, which contains the union of all the data for the bank transactions. So you can see for the shared data, we got interest rate, exchange rate, minimum balance, and maximum balance. Okay? Now, question is, what the problem is that? Do you have any problem for this particular design? Anyone want to try? And before I give you hints. Basically, we have one superclass and we have 4 subclasses, right? That's kind of the design we chose to have to begin with. But now we want to know how suitable or how appropriate it is. Yeah?
Maybe you don't want deposit to have access to the attribute that's 13.
Yeah, exactly. So for example, you can see at the moment, you can see the shared data over here contains all the measures, right? All the data over here. For example, for the deposit, even though we only worry about maximum balance, but am I going to get access as well to other data? For sure, right? Because it's inherited, you inherit all the attributes, all right? That's one thing, yes. There's another problem. So what you just talked about, let me just show you, is more about cohesion. Have you guys heard about this term cohesion? Cohesion simply means for your class, okay, think about when you learn about 2031, did it say about the principle for the Unix system? Do one thing, do it well, right? So basically for every class you have in your Java or Python or C++ or C#, here is a number 1 design principle. You want to make sure you don't want to have a Superman class, which means you put all the attributes and all the methods into a single class. It's going to be giant. It's not a very good design. You want to only put things that are relevant to this particular class, only, and no more. In this case, you can see that at the runtime. At the runtime, if I want to have D of type deposit, think about what's going to happen. For deposit, of course, I'm going to get access to the maximum balance, right? Because that's part of the attribute I will inherit. So maximum balance should be there. But I also get other irrelevant attribute which I don't care, right? So those should not be part of my instance, right? So that's violating cohesion. I should only get access to the things I should worry about for this current class, nothing else, okay? But in this case, you can see we still get exchange rate, and also we get also minimum balance, and also we get access to interest rate. So these are simply not relevant. Okay, that's a design issue over here. Everything might just work, but we want a good design, right? That's why we talk about the design. That's problem number one. What about another problem? Can you see? And the second problem over here is my favorite design principle. It's called single choice principle. Single choice principle, let me describe what a principle is. Let's see if we can go backwards to see what a problem is. Single choice principle simply means my design should be such that every time I want to make a change to anything, there should be either just a single place to change, or there should be just a minimum number of places I should go ahead and change. There shouldn't be multiple places I should go and change. When there's multiple places you want to go and change, make your change, that means your design smells. That means you got duplicates. Now, given that this is single choice principle, can you go backwards and tell me what's wrong with this design?
Each is going to have their own copy of all these attributes.
Aha. Exactly. That's exactly right. So now you can see that, let's say for exchange rate basically changes every day for every hour or every 2 hours. In the current design, think about what's going to happen at the runtime, right? So let's say I got simply like, let me just illustrate very quickly for you. So now think about I got deposit object D1, which has deposit, and which has exchange rate, okay? And then I got D2, I'll just use 3 to illustrate to you, and deposit 3. Okay, exchange rate, okay, deposit, and also exchange rate, and also another deposit object over here. Exchange rate. And then let's say at the moment, exchange rate is simply 0.56, let's say. So now let's say we decide to raise the exchange rate to, let's say over here, 0.86, for example. Now, how many places do you have to go? Well, 3 places, right? You have to go to here and modify that to 0.86. You have to go here and modify that. You got to go here and modify that, right? 3 places, not 1, right? Multiple places. In a realistic system, you might have maybe thousands of objects for each transaction type. In that case, there are so many things you got to manage for the single change, right? So that violates the so-called single choice principle. Okay, I would say it's the number 2 principle you want to know for this course: information hiding and single choice principle. Are we okay with these 2 problems here, cohesion and also single choice principle, right? So I'm not really saying this solution here wouldn't work. It will work. It's just not a good design. Okay, this course is about design, not really just to get something work. Now, how can we solve it? Well, to solve it, we have to let me just show you some slide over here to tell you what the principle is, and then we'll go over some construct before we introduce to you the pattern. Okay, so now, so this is what we just talked about, cohesion and also violating single choice principle. So this is a solution over here. So basically, a very good design is to really have a separation of concern. We want to have the data we want to share, and also another class which is separate, which will encapsulate the sharing itself. So we really don't let the data itself support the sharing. We want to decouple the sharing to another class. What I mean is, eventually, you're going to see data and also data access. So these are the 2 separate classes we're going to support for the Singleton pattern. But we're going to see the details. Yes, question first. You know what? Export status only is for client supplier. When I say, let's say, if I say exchange rate is only exported to, let's say, let's say, particular class. But in the case of inheritance, it wouldn't work. Export status is only for client supplier. It's not for inheritance. You wouldn't help in this case. All right. Okay, so now this might be quite different from how you did it in Java, but I would say we can argue, well, I may argue, this would be a better design. In the sense that we really have a separation of concern. We got data, and also we got the sharing of data itself. Okay, so now, before that, I want to go over some technical stuff with you. Okay, which works a little bit like the static keyword in Java, a little bit like, okay, but not exactly. Okay, it's called once keyword. Okay, so eventually we want to encapsulate the shared access itself in a separate class. But before we do that, let me show you some construct over here. Okay, let me just show you the things directly. Okay, so now we'll go over the code with you, don't worry. Okay, so there is a keyword over here you have to know called once. Okay, so we have a class, let's say, let's make one example. So we have a class called A, and also we got a constructor over here. Okay, simply just do nothing, that's fine. Let's say we support two queries over here, query number 1 and query number 2. For query number 2, it's easy. We simply take a single string, and then we want to return an array of string. And then what do we do for the new array over here? You can see this do, right? Just basically what you have done so far. Okay, nothing special. And then here we say that we simply create an empty array for the result, and then we simply force whatever string we are passing over here to the end of the array, right? And so we can keep growing the array, basically. Okay, so far? Okay, let's test this feature right away, okay, and see what happens. Okay, so now I will say test the query over here, okay? So now let's see the following. So now we have a test over here, and then we simply declare A of type array, and also array 1 and array 2. Okay, that's what we begin with. Okay, we create a new object over here, A. Now, when we say ARR1 is assigned to A.new_array and then Alan, what's going to happen here? According to the definition here. So that means ARR1 is going to point to a new array. Agree? Okay? And the new array is going to be creating some array to be empty to begin with, and then you simply force something into it, right? Okay? So that means we're creating an array over here, and then we simply got and just Alan inside. Okay, just Alan. Just that. Are we okay so far? Okay, it's fine, right? Good. And now, what I want to do is to do another one. Okay? So now let me use a different color here. Let's say we do ARR2. Okay? And then we simply say A.newArray and then mark. Okay, now tell me something. Am I going to get a separate array or just the same array? Look at the definition very carefully. Basically, I'm asking, after I do this particular assignment over here, when I say A.newArray, which is going to call these two lines, right? And then I'm simply passing mark. Question number 1, am I going to modify this particular array or not? No, okay? Apparently I'm gonna have a new array, right? Because you can see that I simply say creates array and then you start to make empty, right? So that means ARR2 is going to just point to a new array over here, whereas we're simply just going to force that to the end of the array. In this case, mark. Like that, okay? And then you can see that's why mark is over there. And now, most importantly, when you try to compare ARR1, ARR2, they are not the same references, agree? They're simply different objects. So far, nothing new, agree? Now, let's see what's going to happen if we replace the do by once. Everything else stayed the same, except that we change from do to once. That's the only change. Okay, it's really important for you to understand that before we get to Singleton. Once we understand this, Singleton pattern will only take 5 minutes. Okay. Now let's go to the second test here. The setup is very similar, except that now you can see ARR1. Again, let me use this. ARR1 is going to be new once array, right? which means we're going to call this particular feature here, and notice that it's once. Without telling you exactly how it's going to do the once, let's just trace the code and see what happened, okay? Now, for the very first time, I'm calling this particular feature that's once. I'm just going to execute the 2 lines as usual. Just do that, okay? So that means ARR1 is now going to point to this particular array. And as usual, we're going to create something empty and then insert whatever that's, the argument is to the end. So that means we still got Alan. So this part is the same as before, okay? What's going to be interesting is in the second. Now, ARR2, okay? So now this is not the first time that we execute this new once array, right? So now it's really important for you to know that very first time that we are trying to call this particular feature. And over here, this is already not the first time. When it is not the first time, what's going to happen is ARR2, okay? Rather than executing these 2 lines, no, it's not the case. We're simply just going to return an alias to the same array. That's why it's called once. Once in the sense that whatever that's within the once and end, they will only be executed once. And when you call that feature for the second time onwards, they only return the reference for that return value to you. That's how we share data. Okay, question first. Good question. Yeah, it's a very good, I forgot to mention, yes. You're basically asking, okay, for the very first time we called this particular array here, we put Alan, right? Alan was actually used as the S over here, right? The first time. You're basically asking, what about Mark over here? Mark was ignored. So typically for once routine, if you really want to have input argument, you have to be careful. Because after the very first time you call that, all the second one and third one and fourth call, the input argument will just be ignored. You don't really use the input argument anymore. It's certainly something there because the compiler say, because your feature requires an input argument, you got to put it. Yeah, just ignore it. Yeah. But typically, the once routine, you don't put any arguments for this reason. But I just want to put it just to illustrate to you. Questions? Well, in this case, basically, mark is never used because for the second call to this particular new once array, we don't actually execute the 2 lines over there. We don't do that anymore. We simply return whatever that's returned for the first time. That's why it's called once. Yes, question?
So what this will be useful for?
Good question. How would this be useful? To be honest, the example I chose over here is quite dumb, but I just want to illustrate to you the runtime behavior. How can this be used? Thinking this way. Since we are trying to solve the problem for sharing bank data, right? Let's say this. If somehow I can make the make feature for the share data a once routine, that means the very first time I try to create a bank data object, it will be created somewhere. All the subsequent attempts to actually create another bank data objects will not create a new data per se. They will only return a reference to the existing data. That's how we share data together. That's how the once routine can be useful. But we'll definitely go over to the details. Yes. Guys, are we okay? Questions? Questions? No? Okay. Yes. Yes, always a reference copy. Good question. You can see it's always a reference copy in this case. Yeah. Yeah. I tell you what, it's a good question. I think if you simply put integer as the return type for the once routine, good question. In that case, it wouldn't be shared because expanded type can never be shared. But typically, if you want to really exploit the once routine for the shared data, you should put reference type. Yes. Yeah. Oh, that's exactly what he just said. So it correct syntactically, it may do that. But the problem is if you use expanded type, as we said before, expanded type cannot be shared. So you may not want to do it, even though you can, but you may not want. That wouldn't do the sharing as we were expecting. Yes?
Is there a mechanism to know if your call actually created using, or if you just got a reference to something?
Good question. So how is everything here managed? That's basically your question, right? IFO does it for you automatically. Think about how you might do this in Java. Why don't we go over Java code, one possible solution to do this in Java. See that very quickly. Hopefully that will help you understand. Since you guys are good in Java, right? How would you do this? What kind of housekeeping do you have to do? Basically, what I want to achieve is like this. I want to make sure, when I try to create, I want to make sure to say I call the constructor for this particular class, but any subsequent call to this particular constructor should not give me a new object. It should only try to give me some reference to the same object. That's kind of what I want to achieve. What kind of mechanism can you think of? I agree, you need static. You need a counter, which can be static, right? You want to check the counter. As soon as after the very first instantiation, the counter will be 1. And then after that, the counter should stop there, and then it should really just return references. Let me show you that. Okay, that's exactly right. Okay, let's go over this quickly, and then we are done. And then I'll finish the singleton pattern next week. Okay, so now let's have a quick look. Okay, for the runs routine, you can just go over the text. It's kind of boring, but exactly what I have just mentioned. Okay, I will also talk about the runs routine a little bit more when we talk about singleton pattern on Monday. But now let's have a look at some Java code. Okay, okay, that's Java, by the way. It's not IFO temporarily. Okay, so now let's say you guys might have forgotten about Java already, right? Maybe. Oh, you should have actually. You should always keep in mind the things you have learned. Okay, let's say we got bank data here. Okay, and then we got interest rate. Let's say just the interest rate. And then we got bank data access, just different class. Okay, separation of concern. And then for that, we got a static Boolean, static data, and also static over here. Okay, and then we rather than using a counter, I simply use a Boolean. So initially false. As soon as I create the very first instance, I set it to be true. Okay, after that, I should not create any new instances. And then I would say over here, you can see that over here, when I say get data over here, it's not really like a constructor per se, but it's going to return to you some reference to some objects. So this is the way we do the mechanism, right? So I'm saying that if it's not being initialized just yet, then I'm gonna create a new instance over here. And then I'm gonna set the init once to be true. You can think about what's gonna happen if I try to call this get data the second time. What's gonna happen? Because for the first time, the init once will be set to true. That means when I call this get data for the second time, this init once, not the case, will just be false, which means I don't really get that anymore. I simply return just the data. Okay? The Java code I didn't want to spend too much time, but you can, if that helps you understand the ones a little bit, feel free to look at the Java code. Yes, question? Okay, the ones, you will see more details about why we use ones, but basically we want to have shared data. And not only that, we want to make sure we have a separation of concern. We want to have data in one class. We want to have data access in another class. So ones can help us achieve that. Okay. Okay, I think that we are pretty much running out of time. So I will continue with this on Monday. Okay, see you next time.